Hello everyone. In this video, I would like to cover some of the key aspects of the project 1 that we're doing in class. So I have preloaded or copy and pasted the code that was given, the script code for R, and it's up here on the top left portion window. You can see the name of it, and right now it hasn't been saved because it's in red. And the way that you're going to go about this is that you want to place your cursor where you want it to start executing, and then we're going to hit run so that we can verify that what we are putting into the code is correct. So the first part of it, right, as you can see down here in the console, is the actual output. It is executing. Think of this as like a verb. It is actually doing something, and we're getting an output. Okay, as we defined the variable a with the dataset chick weights, you will see on the right side where we have the data portion of the window, you can see that something has been created. It now tells you that there is 71 observations, which is the number of rows, and then 2 variables, which are the number of columns. Okay, let's keep going and press run. And what it's doing is that it is creating a subset of the data. And for you, it may look different than for me, but you now have a B variable that you're about to create, and it is a subset of 60 observations from those 71. Okay, and so we keep going. Here is perhaps one of the first edits that you have to do. You need to put your name right here so that when the output is executed, or the code is executed, that your name comes up so that I know it's your project. Okay, so after this is where we begin the project, if you will. Here it says print out the structure of the data frame. So print str of the variable b. Str is the function structure. And so if we go back to the project, we are starting to be here in task number 5, where we begin figuring out the length of the vector variable. So this is part of the descriptive statistics. So if we go back, we get first the structure. We know that it's a data frame. It's got 60 observations, 2 variables. One variable is weight, the other one is feed. Okay, so we keep going because really we haven't had to do anything yet. Here, where we get the first output, quantitative data, is where we're going to start changing things. Okay, so the first thing that is already given is this. There are 60 observations in the data frame. That's the first answer, pretty much. Length of the vector variable. It is 60. There is 60 observations. Then we want to find the mean. Well, we do that by calling the command mean. So we have to type it in here to concatenate the code, and we can type in by putting quotation marks the mean of the weight variable, because the weight variable is the one that is the quantitative one. It's the numerical one. Mean of the weight variable is. We leave a space. We put a comma outside, and we do mean of B variable, which is the subset that you're using, right? The new set of data, and then we got to put $sign so that we can specify which column or which variable I would like to use. And then you can use your keys, up and down arrows, to select or finish typing the variable. But because we're looking for the mean of the weight, we do this. So the mean of the weight variable is, and that's going to output a number, and we would like to do this backslash n so that it gives us a new line. Okay, so I think we gotta put this in double quotation marks so that it skips the line. And so the mean of the variable weight is, and right here on the bottom we see that it actually works because it executed without giving us any errors. Then we want to find the standard deviation, we want to find the variance, and we would like to find the 5-number summary of the variable. These are things that we can do in R. Somehow we got to find the standard deviation. I'm sure there's a command that I would like for you to execute there. There is the variance, and then the summary. If you remember, we talked about there is a summary command, and so real quick, I will do that here. I'm going to leave room, right, because I need the standard deviation, I need the variance, so I'll type that in so that you kind of know it's a placeholder. So standard deviation, and then we'll do the back end so that you know that it's going to skip a line, right? So there's got to be some kind of numerical value that goes with it. And then let's go back up and type in the summary. So the summary, where the 5-number summary is, or whatever. You can put in like something like this. Okay, so this is going to allow us to get the 5-number summary, right, where we get some numbers, and those numbers mean something, right? Like the 108 is something, this 205 is something. Okay, so that kind of leaves us with task number 5 that's completed. Then task number 6 for the qualitative variables, print out the frequency counts. So next section is right here commented out. It says print out frequency counts for the qualitative factor variables. So qualitative, also known as factor variables. So we are going to execute that line of code and see what it gives us back. It prints out, you know, that we are in the qualitative data category portion of things. And if we hit run, it's automatically already giving us those counts. So the frequency counts for the feed types are 10, 9, 10, 9, 12, 10. Meaning that for category or factor number 1, there is 10 occurrences. For the second factor or the second kind of qualitative variable, there is 9, and then 10, and so on. Okay, this is one way to do it. Another way to do it is that you can just print. So we can say the same thing. So the counts are, for example, and we can we print inside? I don't think we can. Let's print the table of the variable feed counts. Okay, so that it gives us a table. Kinda. It didn't come out as expected. But that's another way to do it, you know? So those are the counts, pretty much. What's next? Task number 7, which is the plots. So here we would like to do first a histogram, and we're doing plots for the quantitative variables. So as we go through, we have our first command that's given to us, and that's the histogram. As you execute this, it creates a plot. And so many of you may have gotten this numbers, and they mean something only if you have the graph or the plot. So I can scroll back up, and here's the command that was executed, and here's the outputs. So what's going on is that we get this plot on the right side. Okay, now we want to edit that plot because it's just the default, and we don't really want it to look like that. So we are going to hit comma and type in main so that we are able to edit the title of it. And this is what? Histogram of the weight. That will be the title of it. Then we would like to change the labels, like the X label, and that's going to be the weight. I believe it's in grams. You can do that if you like. And then we can leave it like that. Once we hit run on that line of code, we see that we do not have a new histogram. Let me see. Did something happen? Yes, something did happen, and all of this, is supposed to go inside of the histogram call. So the histogram command takes in this first input, and then there's all these other options that we're allowed to change. And so let's run it again. And so now we can see that the picture on the bottom right changed. It now has a new title. It now has a new X label. Okay? So this is the frequency histogram. Next, we would like to do the relative frequency. And this is fairly simple. What we're going to do is copy this line. And so what we're going to do is change the title. We'll call it relative frequency. And I'm going to give it a couple spaces so that we can see what's going on. Histogram. Now, if we do not want a frequency histogram, we want a relative frequency, we will hit false, and it tells us a density or percentage wise. Okay, and so this is what we're looking for. We're looking for one of them being the frequency histogram and the other one being the relative frequency, which changes the vertical axes. One of them is counts, the other one is a percent or a ratio of that. Okay, so that is histogram number one, frequency and relative frequency. Then we would like to do a box plot and a modified box plot. And so if we remember, I'm going to do it here, box plot of B of the weight. Okay, it depends how you want it. We'll do it horizontal so that it's like this, and we can add X label so that we have a nice picture. And so this X label is going to be the distribution of the values of weight, so weight values, if you will. And let's run that, and here on the right side we see our box plot, how the data is distributed, the X label, or the title, kind of, in a way. Now, what is a modified histogram, a modified box plot, is that if you have any outliers, then all you have to do is really just type range equals 0, so that whatever outlier is there, it still gets connected to the whisker, but in the case of your data, perhaps it may look the same. So the modified and the regular box plot would just look the same. Okay, so it may or may not be any difference depending on your data. Next, we would like to do a stem and leaf plot, arguably a plot. How do you do that? Well, there's a command in R which is called stem, and we just plug in, or we call the command stem, and we select our variable, and then which column or which variable inside of that larger variable do we want. Oh, sorry. And so we just hit run, and the plot for that is this. This is a stem plot, meaning that this is the 10th value, and this is the ones value. So I have a 11, I have a 12, I have a 14, 14, 14, 14, then there's a 15, 15, 16. So these are all the individual values in the data set, or the variable of weight, but it is now displayed in a different way, and you can see that this one has more occurrences. This one has way more occurrences, so we can say that there's more weights that are in the range of 30 to 34 than any other weight. And then the weight of 40, there's only one occurrence of it, right? We're able to look at the data from a top-down level and just kind of determine what's the most occurrent. Okay, so that seems like it is the stem and leaf. Now, a modified box plot of the data broken down by factor levels. So this one's a little bit more complicated, and here is that. We're going to do a box plot, and what we want to do is that we want to do the B variable by the weight, and then we're going to use that symbol at the very top left, right under the escape key, that looks like a tilde in Spanish, and we do the weight by the feed. Okay, so now let's run that code and see what we get for that. Okay. And here on the picture on the right side, maybe you can tell that there's a bunch of outliers for the data. Okay, there's a couple dots that are just kind of flying around. Now, it is a modified box plot because we want those outliers to be included. So we're going to go back here and tell the range to be 0, and then we were going to edit a bunch of things about it. We would like to add a label for the x-axis, so it's not this ugly label. We would like to also add a y label, so it's not that B money symbol weight. We would also like to add a title to it, but for the most part, this is what I'm going to show you, so that you can see the difference now between the previous plot and this one. Is that the previous one had the dots and the shorter whiskers. This one has been modified. Okay, what's next? Yeah, as stated here, note that each graph at minimum should have a title and the axis label should be clear. Then we would like to make, or task number 8 is to make a bar plot of the frequency counts and then a pie chart. So we'll come back to this, and the bar plot is given to us. So all we have to do is hit run, and here's the bar plot for my data. Now it's missing the pie chart. Same thing. You would need to use the pie command, and we're looking at our previous variable, which we define as feed counts, because we would like to display using the pie chart. And so that came from right here, where table b variable of the feed factor. So we created a table, or we turned that column of the data into a table so that it's easier to read, and we named it feed counts. So pie, and then we'll type in the feed counts. And for now, I'm just going to display it. And this is it, kind of. I would like for you to have this equals whatever number of counts are in here. Okay? And so maybe there's a little bit extra code that needs to go into this, but essentially that's it. Underneath is all the answers that should go for the project. You know, answer 3, whatever answer you believe it's the answer. 4, 5, 6, 7, and that's it. Those are all the questions that need to go on to this. Thank you for watching.